Good morning.
Good morning. Good morning.
He looks like a total dad.
All right, so how's everyone today?
Good, how are you?
I like your hat.
Oh, thank you. Do you recognize it? Logo?
Yeah.
What is it from?
Avengers. Isn't it like the Shield logo?
It's the Shield logo. This is the hat that Nick Fury wore in the Captain Marvel movie.
Mr. Straw?
Good job. Yeah.
Sorry, Naomi and I have a performance today and we're getting checked out during this class halfway through at 11:30.
What are you performing?
We're in Camp Rock for the select
All
choir.
right. I'll let you go if you sing a little bit for us really quick. No, just
You're
kidding. Just kidding.
I don't want you guys to have that stuck in your head all day.
Camp Rock. So is that like School of Rock?
Think of High School Musical, but like at a summer camp. It's super cheesy.
Okay.
Yeah.
All right. So is this like torture for middle school? No, I'm just High School Musical. Actually, I enjoyed that. That was kind of fun. So
Yeah.
is this like a middle school version of like the songs, or is it more still high school?
This is for girls.
The high school a little bit. Is it?
I don't know. I have no clue. It's just really cheesy.
It's a summer camp, so they don't really
Okay.
tell you what the ages are. But they're pretty young.
Okay. All right. Well, that sounds fine. All right. So I won't wonder when you walk out.
All right. Thank you.
I'll try not to take it personally.
Okay. We're sorry.
Oh, that's good. Okay, so what about let's see, anybody else absent in Holbrook?
No, everyone's here.
Okay.
I think.
No.
Wait.
Yeah.
Yes.
And then we've got Avery out. He texted me. Anybody else gone and chose the same?
Jay is at the same presentation that Avery is.
Jay is at the same thing. Okay. All right.
Hold up. Wait, we're missing two people.
Okay.
Serena's not here.
And Serena and who else?
That's it. Audrey, Desiree, Raylin, Caitlin, Myers, Tara, Madison, Sierra. Okay, yep, just Serena.
Just Serena.
Okay. Alrighty. Okay, so today we're going to finish up 7.1 and start in on 7.2. Let's see. Okay, there we go.
Professor Strong, would you
Yes.
mind doing a problem from the book?
I do not mind that at all.
Awesome.
So let me know what problem.
Okay, it's page 561, problem number 5.
Page 561, problem 5. Okay. Okay. Let's start in on that. Okay. All right. So So we want to simplify. Let's see. It says use trig identities to simplify the expression. There may be more than one correct answer. So do you remember? You remember me saying that I actually like the problems where you verify the identity. I like those better than these because this you don't really know when you're done. Okay, and so like when you work on it and then check the back of the book, it might not match. And so that's probably what's happened here. So it can be kind of tough. So the first thing that I see is to get rid of this negative t. And so the even odd identity, the sign of negative t, does the negative go away or do you put the negative in front?
It's in front.
Yes. Okay. So you have negative sine t. And then I went ahead and broke down tangent as sine over cosine, hoping that some of them would cancel, but it doesn't. So you end up with negative sine squared t over cosine t. Okay? Probably at that point, I would check the back of the book and say, please let me be done. And you look and you're not even close. Okay? So then you say, well, okay, I could write everything in terms of cosines. Okay, so using the Pythagorean identity, write negative sine squared t as 1 plus cosine squared t. Over cosine t. And then you can actually split it. You split the fraction and say, well, that's 1 over cosine t plus cosine squared over cosine t. And then 1 over cosine is secant, and cosine squared over cosine, one of the cosines would cancel, so you get cosine. And then you check in the back of the book, and that is the answer. But to me, these are a little frustrating because you don't really know when you're done. I mean, unless it simplifies to some like easy thing.
The answer is pretty similar to that. I guess.
Oh, but it's still not that?
It's cosine of x minus secant of x. So it's
minus.
Yeah. But they're flipped. Cosine of x minus secant of x. Or t.
Minus.
Yeah.
Oh, wait a second. Look. I've got a mistake right here. See, when I brought the sign over here to make it negative sine squared, but then when I move the 1 over here, it should be negative. Okay? So let's rewrite this. Okay, let's rewrite this. So this should be cosine squared t minus 1. Okay, so then, okay, so let's change that to cosine squared t minus 1. So then okay, so then this would become cosine squared t minus 1 over cosine t. So then cosine t minus secant t. And is that what they have?
Yeah, it is.
Okay. All right. So see, I wouldn't have picked up on that sign mistake if you hadn't said that it should be minus there. So, So thank you for that. All right. Any questions on that? Any other questions? So I want to commend you, Lauren, for working on the practice problems, number one. And number two, not even waiting till we're done, but actually, even though we're in the middle of it, you've already started it. And frankly, that's what an A student would do. And so it's no wonder that you're an A student in here. So good job. Keep it up. Okay, well, let's get back to where we were. Let's see here. Okay, we were with the factoring part. Okay, so we were talking about different algebra tricks to simplify, and this was the next one. When factoring trigonometric expressions, it is helpful to find a GCF. So factoring becomes sort of the next, and we mentioned this on Tuesday. Rewriting of sines and cosines, getting common denominators and combining fractions. And then factoring, that's another very useful algebraic skill to apply to these problems. All right. So, for example, here you see a cotangent squared x and a cotangent squared x in each term. And so we can factor out a cotangent squared x. And then we'd have left 1 from the first term minus sine squared. Well, then hopefully you've done enough of these that when you see 1 minus sine squared, then you go, oh, that's got to be cosine squared. And then you have cotangent squared times cosine squared, and that's probably okay as a final answer, but you might just look to see if you can simplify that. Cotangent is cosine over sine. Unfortunately, nothing cancels here. And so then we would end up with cosine to the fourth over sine squared, and that's probably okay. You could leave it like that. You could actually leave it like this up here. You could try to, maybe rewrite it as all in cosines and see if you could break it down. But this is good. Okay? And because really the main thing I'm wanting you to learn from this is the idea of factoring out a common trigonometric function. Okay. All right. So let's have you try practice 3B. So factor that out and simplify it. All right. So Ricky, what can we factor out of this one?
secant squared x.
Secant squared x. And then when we factor out a secant squared x, then we have tangent squared x plus 1. And so then what's that equal to?
Secant squared x.
Okay. All right. And then, so Ricky, what's secant squared x times secant squared x?
Is it secant to the fourth x?
Secant to the fourth x. All right. All right. Good job. Now, if you wouldn't mind, Ricky, and anybody else, try to limit the use of your phone to emergencies only, because I really need your focus, and it really will help you understand what's going on. So, okay? All right. So good job on that. Okay. Let's see. So the next part is to, let's see here. All right, sometimes we can simplify an expression by simplifying one side of an equation at a time. All right, so here's an example. So when we're trying to simplify this, I mean, this looks pretty crazy. This looks not bad, 1 over sine or something. But typically, when we're trying to simplify one equation, one side at a time, you start with the most difficult part, okay? And so for this one, what we want to do is get a common denominator and add those fractions together. So, so what we're going to do is multiply 1 top and bottom by 1 minus sine. So we're rewriting 1 as 1 minus sine over 1 minus sine. Why? So that we have the same denominator, 1 minus sine. Okay? Now we can write them together as one fraction. Now, the thing you got to be a little careful with is this negative here. Is the negative applies to everything in the numerator, so when we combine them together over one denominator, you have to distribute that negative. And so, so then there will be minus 1 minus a negative sign will become plus sign. Okay, so let's see, is there anything else we can simplify here? Well, let's think of cotangent as cosine over sine. That didn't really help me here. All right. Can anybody see what to do here? This is getting worse. Well, it's worse because of this. When I rewrote this as sines and cosines, usually that makes it better. But see, this made it a complex fraction. So then what I think, well, to get rid of a complex fraction, if we multiply by the little denominator here, sine of phi, so multiply everything by sine, top and bottom. So then what happens is this sign will cancel with that sign, and we won't have a complex fraction anymore. Then you'll have minus 1 times sine plus sine times sine. So that's going to be cosine squared minus sine plus sine squared. And then in the denominator, I have sine times 1 minus sine. Now, typically, I don't multiply that out because I might be able to cancel it. So you don't want to multiply that out. All right, so now, anybody see anything I could do to simplify?
Well, there is the one on the bottom, the 1 minus sine. Isn't that equal to cosine squared?
No,
Oh, wait, never mind. That's
it would be
sine.
1 if it was sine squared.
Yeah, never mind. Okay.
But you're actually thinking along the right lines here. Because what is sine squared plus cosine squared equal to? 1. So I can take the cosine squared here and the sine squared here and rewrite it as 1. All right? And now you can cancel the 1 minus sines, that whole term, and end up with 1 minus sine, 1 divided by sine, which is cosecant, which is what we wanted to show that it was equal to. Okay? So we're done. All right, so let's see if you can do practice 3C. All right, so Desiree, tell me what to do first.
Can I get some help?
Sure. Well, did you try anything?
Well, I tried. I don't know what I'm doing.
Well, no, that's okay. It's okay because we're all new at this, all right? I mean, you guys are doing a great job, but you can't be paralyzed by the problem. You have to try something, okay? All right, so anybody have a suggestion?
Maybe you could like put it in terms of like sine and cosine, except then you have the cotangent that doesn't make that work very well.
Okay, so if we put everything in terms of sines and cosines, cosecant is 1 over sine minus sine, and then if we wanted to work with this side a little bit, then you never know. Sometimes stuff might cancel, but you get cosine times cosine over sine. All right, so does anyone have an idea what to do next?
If you did like the right side, if you did like cosine x times cosine x and like had cosine x squared, would that help any?
Well, it will later. We're going to want to do that. but here's the kind of the way that if you think about it like this, when you have an equation with fractions, I mean, that's what's bothering us here, these fractions. How do you clear the fractions when you have an equation?
You multiply it to the other side.
And what do you multiply exactly?
The denominator.
The denominator, the least common denominator. So if you look at you have a denominator here of sine x, a denominator here of sine x. Well, if we multiply both sides by sine x, we're going to get rid of our fractions. And so that's going to be nice. Okay? All right, let's see here. Well, okay. All right. Oops. Okay, so here we did 1 over the sine of x minus the sine of x equals cosine x times cosine x over the sine of x. And so what I'm saying is that if we take that and multiply both sides by the least common denominator, then we're going to get rid of those denominators. So I'm multiplying both sides by sine of x. Okay? So on the left, sine x times 1 over sine x is what? One minus sine x times sine x, sine squared x equals, and then I cancel the signs here, and I get cosine x times cosine x is cosine squared x. And guess what? That's an identity right there. Because 1 minus sine squared x, you could just write it, that's equal to cosine squared x equals cosine squared x. Okay?
Mr. Strong, I have a question.
Okay?
So when you have cosine x times cosine x over sine x,
Yep.
you can multiply the whole thing by sine over x and it gets rid of the denominator on both cosine x's?
Well, this is just the one denominator. You could think of this as cosine x over 1 if you wanted to.
Yeah,
but it's kind of like if I had, let's say 3 times 1/2 times 2. So you're saying if you multiply by 2, you get rid of the 2 underneath both of them? Well, it doesn't really, the 3 doesn't really have a denominator, or you could think of it as a 1.
Wait, so if it doesn't have denominator, doesn't that mean that if you
Well, you could
multiply
think
the
of it
top
as
by
like over 1. It's if it doesn't have a denominator written, you can think of it as over 1. Or you could think of it as cosine squared over sine x, but it doesn't have a separate denominator.
But then you'd get then you'd get 6 for the 3, wouldn't you, if you're multiplying the whole thing by 2?
No, because the 2's would cancel.
Oh, I see. Okay, never mind. Got it. Thank you.
All right, that's okay. All right, any other questions? Okay. All right, trig substitutions. Use substitutions to write algebraic expressions as a function of the angle. Okay. So this is using a substitution, a trig identity. This is kind of something that we would do in calculus, okay? And so this is, the idea is this. It says use the substitution, x equals 2 sine theta, to write the square root of 4 minus x squared as a trig expression and simplify, okay? So in place of x, we're going to substitute 2 sine theta. So we would have radical 4 minus, so in place of x, we're substituting 2 sine theta. Okay, so now we square that. And we get 4 minus 4 sine squared theta. Okay, now we can actually factor out a 4 there. And so we get 4 times 1 minus sine squared theta. So using a trig identity, what is 1 minus sine squared theta equal to?
Cosine squared theta.
Cosine squared. Okay, so then we end up with 4 cosine squared theta. And now both of these are perfect squares. So the square root of 4 is 2. Square root of cosine squared is just cosine. And so that's my answer, 2 cosine theta. All right, so go ahead and try practice 4. I'll leave this one up for a minute so you can kind of see. All right, so Anna, when you've got it.
I need help.
Okay, so in place of x, we're going to substitute in 2 sine theta. Okay? So we're going to get the square root of 64 minus 16, and then in place of x, we have 2 sine theta squared. Okay? All right, so now when we square 2 sine theta, what do we get?
4 sine squared theta.
4 sine squared theta. Okay? And now, what's 4 times 16?
64.
64. So then we have 64 minus 64 sine squared theta. So what can we factor out of that expression?
The 64.
64. And so then 1 minus sine squared theta. And 1 minus sine squared theta is equal to?
Say,
What? Oh, cosine squared theta.
Cosine squared theta. And now, each of these are perfect squares. So my final answer is going to be?
8 cosine.
8 cosine theta.
8 cosine theta. Okay, good job. All right, any questions on that? Okay, going good. All right, well, that's it for 7-1. So if you, continue to do practice problems and come to me Monday with more questions on that. Okay, we're happy to do those. All right, let's go ahead and go on to 7-2. Okay. So 7-2 is on sum and difference identities. And so the big idea here is now we're going to be able to sort of expand our use of the unit circle to give exact values of trig angles that aren't on the unit circle. Okay, so like, for example, the sine of 75 degrees. Well, right now, you look in the unit circle and you don't have that. But now I'm going to show you a way that you can get the exact value of that. Okay? So we're not going to be using our calculator here in this section. Okay? We're going to be expanding our use of the unit circle. Okay. So we start off with the identities. And I had asked you to go through this chapter 7 and write down the identities. So hopefully you've done that. If not, then, make sure you do that. I do want to draw a couple of these to your attention here. Okay, the cosine identities. So these are the ones that most students make a mistake on with the sines, because the cosine of u plus v has a negative in there. And the cosine of u minus v has a positive in there. So that kind of works opposite the way that you would think. So when you're writing down those formulas, make sure that that's accurate. And then on the last two, the tangent identities, you'll notice I left a little bigger space on those because I actually add these two identities that are not in your book. Okay, so hopefully you've written down these two for tangent of u plus v and tangent of u minus v. But if I've already found the sine of u plus v and the cosine of u plus v, I use this. Or same with tangent of u minus v, I'll use that. Okay. Now, okay, so depending on how you're going to take the tests and the quizzes, all right, if you're going to use the sheets, the guided notes, or if you're going to use the back of the book for your formulas, if you think you might use the back of the book, then go ahead and write these formulas in for the back of the book. I've had some students in the past do that, so you might see on the back of your book, they might have already be they might already be written in. All right. So I'm going to let you copy down these formulas later. Outside of class, I'm going to go ahead and show you how to use them. All right. So the first thing we want to do is to be able to learn how to break down angles as sums or differences of angles on our unit circle. So I mentioned 75 degrees. So can you think of how you might combine two angles on the unit circle to get 75 degrees? Either adding two angles or subtracting two angles.
35 and 40.
About 30 and 45.
45 and
There you go.
45 and 30. Yeah.
So 45 and 30. Okay. So that's the first skill you need to be able to do is break down the angles. Okay. So let's have. So now on your practice problem, write 105 degrees as the sum or difference of common angles. So by common angles, I mean the angles on the unit circle. All right, so Caitlin, what do you think? So two angles on your unit circle that would either add up to 105 or that you could subtract and get 105.
Yeah.
Can you turn on 60 and 45?
60 and 45, exactly. Okay. So then we're going to use those formulas, but see, we're going to use those angles, the 60 and 45. That's going to help us come up with the exact value here. Okay. Or if we're doing 75, we do the 45 and 30. Okay. So the sum and difference formulas can be used to find exact trig values of these other angles. So we're looking for the angles that are on the unit circle, and they'll help us find the exact sine, the exact cosine, or whatever. Okay? If you put them in the calculator, you're not going to get the answer that we need most of the time. Okay? All right, so let's say I wanted to find the exact value of the cosine of 75 degrees. Okay, so the first step is to rewrite 75 as 30 plus 45. Okay, so the cosine of 75 degrees is the cosine of 30 degrees plus 45 degrees. So that's the first step, is to break down the angle to two that you know. All right, the second step is to find the right formula, okay? So the cosine of u plus v, the formula is, the cosine of u plus v is the cosine of u times the cosine of v minus the sine of u times the sine of v. Okay, so the minus is what a lot of people mess up. All right, so now, wherever you see a U, you're going to plug in 30 degrees. And whenever you see a V, you're going to plug in 45 degrees. So this is going to be the cosine of 30 degrees times the cosine of 45 degrees minus the sine of 30 degrees times the sine of 45 degrees. Okay, now you pull out your unit circle or your special triangles, or maybe you have these values memorized, whatever. And you look them up and you say, okay, the cosine of 30 degrees, that's radical 3 over 2. The cosine of 45 degrees is radical 2 over 2. Minus The sine of 30 degrees, that's 1 over 2. The sine of 45 degrees is radical 2 over 2. So when we multiply this out, we get radical 6 over 4 minus radical 2 over 4. And now we have a common denominator, so you want to put them all over 1, but you can't really add these because they're not like terms, so, or subtract them. So this is your final answer. Radical 6 minus radical 2 all over 4. And so that's what the answer to these problems, they typically look. They look like that. Radical 6 minus radical 2 over 4. All right, so now what I'd like you to do is practice 2a. So where you're going to find the sine of 75 degrees. So you're going to break it down the same, but you're going to have a different formula to plug in. Okay, so see if you can do that. All right, Jay, welcome to class. When you've got the answer, let us know. All right, you need some help?
Yeah, I do.
Okay, so the first step is you break down the angle to 2 angles from the unit circle. So we're going to use the 30 and the 45 again. Okay? All right, so now the second step, you look up the formula. Okay, so if you haven't written those on the paper yet, look in the back of your book. They have the sum and difference formulas. And so you're looking for the sine of u plus v. So then from the back of the book, you find the sine of u plus v is the sine of u cosine v plus cosine u sine v. So any questions about the formula? So now everywhere you have a u, you're going to plug in 30 degrees. And everywhere you have a v, you're going to plug in 45 degrees. So this ends up being the sine of 30 degrees, cosine 45 degrees, plus the cosine of 30 degrees times the sine of 45 degrees. All right, so now you look up on your unit circle or your special triangles. So Jay, what's the sine of 30 degrees?
1/2.
1/2. And the cosine of 45? It's radical 2 over 2.
Right, yeah.
Cosine of 30 degrees, radical 3 over 2. Sine of 45 degrees is radical 2 over 2. So now when you simplify each of these, you get radical 2 over 4 plus radical 6 over 4. And so then you get, just combine those under one denominator. So radical 2 plus radical 6 over 4. All right? Any questions on that? All right. You good on that, Jay? You feel okay about it? All right. Awesome. Okay. All right. Well, let's do the tangent. Okay. So when finding the tangent of u plus v, you can use the formula that's in the book or the one that I gave you, which was the tangent of u plus v is the sine of u plus v divided by the cosine of u plus v. Okay, so in the practice 2b, it asks you to find the exact value of the sine of 75 degrees. Okay, so you just found the sine of 75 degrees. So to get the tangent, sine over cosine. So you found in practice 2a the sine of 75 degrees. Okay, in example 2a, I gave you the answer for the cosine of 75. Let's see. Sorry. Okay. So this was our answer for the cosine of 75 degrees. So see if you can simplify that. Okay, so this is what we got for the sine of 75 degrees. This is what we got for the cosine of 75 degrees. Okay, is there anything we can do to simplify that? Again, we don't like complex fractions. So how can I get rid of the complex fraction?
Well, I just flipped I took the reciprocal of the denominator and multiplied.
Okay, and so then what's going to happen then?
And then you get like a 4 times the 2 radicals in parentheses over the other one, and then the 4's can cancel.
The 4's cancel. So you can actually do that from this step. You can actually cancel the 4's. So like this, you could do